Hi there. In this video, we will learn about NPV, and in this case, the NPV will be applied on a situation when there will be different possibilities of timing of the benefits. Let us consider an example that will guide us about this certain situation of NPV application. We are considering that we are going to make a bridge on temporary basis, and once the purpose of that bridge is served, then it will be decommissioned. So for that we are going to do NPV analysis. But what should be the timing of those benefits? If the timing of the benefits, if they change, then what will be the effect on NPV? This is what we will see here. So 4% is the discount rate that we are going to use, and time for the costs, it starts from now, 1 year after, 2 years after, and 3 years after. This is construction cost, and this is the amount of it. And it is incurred in the first in the time period when the project starts, and afterwards definitely there is no further need for construction costs. And then once the project is completed, the decommissioning will take place, which will require a certain amount of cost. So it is at the end of the time span, that is in third year. Now we consider their discounted versions, that is the discounted construction cost and the discounted decommissioning cost. So we can discount them easily on the basis of 4% discount rate. So after getting the discounted versions of the two costs, now we can sum them to get the total cost in their discounted version. So this will be the sum of these two discounted columns. This is the overall value of the discounted costs. So this was about the cost, and now we are going to treat the benefits. Benefits, they will start from the year 1 and they will go to year 2 and then year 3. Definitely in the time period when the project starts, there will be no benefits. After the construction, there will be benefits, that is from the first year. So we are mentioning time separately here for the benefits, and we are not following the same column here because the timing of the benefits will differ. So we have to give it a separate column for benefits for all those possibilities. For example, the next possibility is here, and then there will be two further possibilities. So this possibility is actually that the benefits will occur at the end of each year. It means that this is the first year, the completion of it or end of it, completion of the second year, and completion or end of the third year. So the benefits, they are also given. These are the benefits on a yearly basis. The discounting factor, it is mentioned here, which we can use to discount the benefits. So this is the discounted benefits column, and after this we can sum this column and we will get the sum of the discounted benefits. Now the sum of the discounted benefits minus sum of discounted costs will give me the NPV of the situation where at the end of each year the benefits occur. So the difference is negative, that is the NPV is undesirable and we should not go for the project in this situation. Secondly, this is a point to note that we are going to do the netting after method here, but not netting before, because in this case the time span is having different occurrences. That is, in the beginning of the project there is a cost, but in the beginning of the project there are no benefits. Definitely after the span of 1 year there will be some benefits, but then we also consider that the benefits are occurring at the beginning of each year. This is also a possibility in projects that are based on IT, because they have a very rapid deployment and the returns can be very rapid. So this can happen in certain situations. So this is why it is better to do the netting afterwards. Primarily we can separately discount the costs, and then we can separately discount the benefits, and then we can net them mutually. So the second case will be that the benefits are occurring in the beginning of each year, not at the end, just like in the first case. You can see this set of columns, they are the same, and the discounted cost in overall sense it is also the same. However, the benefits, they are occurring in a way where in the beginning we have the benefits, rapid benefits, in the beginning of the first year and the beginning of the second year. So benefits are for the 3 time periods, that is first time period, second, third, but not at the end, rather in the beginning of that time period. So benefits, they are mentioned here. Again, the discounting factor is calculated, but this time you see that the discounting factor for the first row is 1 because the time is here 0. Accordingly, the discounted benefit for this first time period are the same as the undiscounted benefits. The remaining 2 years have discounted versions of the benefits. Now we take the sum of these 3 discounted benefits and we will get the sum of the discounted benefits, which we can treat with this sum of the discounted costs to get the net benefits in such a net present value in such a situation where the benefits are occurring in the beginning of the each time period. Now it is positive. So it has turned positive from negative. Now it is positive. The third possibility is here now, that the benefits, they occur in the mid of each year. Again, the cost column will remain the same because we are talking about the occurrence of the benefits and not of the costs. So they will remain the same, and the benefits, they will vary in terms of their occurrence. You can see that it is 0.5 for the first time period because this is the mid of the first time period, that is from 0 till 1. The midpoint would be 0.5, that is after 6 months if the time period is 1 year. And then we have another point, that is 1.5, that is in the mid of the second year, in the mid of the third year. So again, we can calculate the discounting factors accordingly. The formula will remain the same, it will not change no matter we have the time value in fractions. So the discounted benefits, now they can be summed, and then we will get this value, which is the sum of the discounted benefits. And here we have the sum of discounted costs. Their difference will give us the NPV, and which is equal to this, and this is the NPV when the benefits, they occur in the middle of each year. So till now the observation is that the NPV is now positive. It was negative before, then it became positive, now it is again positive, but still it is not greater than the second case. We will compare all 4 of these cases once we are able to find the result for the 4th case. Again, we don't have to any treatment to the cost because it will remain the same, but the benefits, they will be treated in a different way. So for this case, the benefits, they are split equally between beginning and the end of the year. It means that half of the benefit will occur in the beginning of that time period, and the remaining half will occur at the end of that time period. So this is the first year, this is the second year, and this is the third year. This is actually the beginning of the first year, end of the first year, beginning of the second year, end of the second year, beginning of the third year, and end of the third year. So we are going to write the value by dividing it by 2. Here the half of it would be this much, so half of it occurs in the beginning of the first year and half occurs at the end of the first year, and the half of this value will be this. So half of it occurs in the beginning of the second year and remaining half occurs at the end of the second year, and this would have a half of this much. So this half will happen in the beginning of the third year and the remaining half will occur at the end of the third year. So this is how the benefits are split equally between the beginning and the end of the each year. Remaining process would be in accordance to the standard procedure. Discounting factor for t is equal to 0 will be 1. Discounting factor for t is equal to 1 will be this, and then discounting factor will be the same for the next time period, and then for these 2 years, that is time periods, it will be the same, and for t is equal to 3 it will be this much. So now the discounted benefits can be easily calculated. These are the discounted benefits. The sum of it would be this, and then we can take the difference, giving us the NPV. When the benefits are split equally between the beginning and the end of each year. So this will be the NPV. Half of it, and all these rows are explaining what we said and observed in these columns, and you can pause the video and read this. So now the interpretation. What we have observed is that if we shift the benefits earlier, it increases the value of NPV due to lesser discounting. Definitely, the earlier the benefits occur, the lesser will be discounting. The more we go into the future, the more will be discounting. This is why the comparison of all 4 NPVs will be like this, that when we consider that the benefits occur at the end of each time period or end of each year, the NPV is the lowest, and it is negative in this case. And if the NPV is calculated for a situation where the benefits are occurring in the beginning of each year, the NPV is maximum. Then comes the case when they are split equally between the beginning and the end. So it is greater than that when the situation is that the benefits occur in the mid of each year. So in the case of split, half of the benefits, they are occurring in the beginning of the each year, which makes it more desirable as compared to when the NPV occurs, the benefits occur in the mid of each year. So this comparison is quite intuitive. We can also compare it with the help of these flow charts. As you can see, now all 4 of these are visible in the same screen. Present value in case of the beginning, present value in case of the splits, and present value in case of mid, and present value in case of end of each year. So the benefit was occurring in the beginning of the first year, and in the beginning of the second year, and in the beginning of the third year. Benefit here was occurring, half of it occurring in the beginning, and remaining was occurring at the end of the first year. So this is the situation. We have taken a few values out of those split cases because there are 6 values, but we have chosen 3 of these, the first split and the second split, and then for the second year the first split, then there can be the remaining splits. Then we have the occurrence in the middle, and in that case you can see the half of the time when it is spent, the first benefit will occur, and when 1.5 of the time period is spent, the second benefit will occur, and so on. And finally the present value when the benefits occur at the end. Then when t is equal to 1, that is a full year has passed, then the benefits occur, and then when the second year is passed, then full benefits occur. Finally for the third year the same will happen. So this was the graphical representation of these 4 cases. This was the value comparison, and then we have the calculation that we did for all of the 4 cases. And we must remember that we should do the netting after procedure here, so that we be able to do the calculations separately for benefits and the costs. As the benefits, they are occurring separately in different possibilities with respect to time,